Hello everyone. Today we'll be starting another chapter that is probability. And for that, later on, after a couple of sums, you'll see that you'll be needing your concepts of combination also. So I hope that you all have that handy. If not, then after today's class, make sure that you revise combination to have a complete understanding of the sums that will come after that. So when we hear the word probability, there are certain words that come into our senses, right? Chance, something that may or may not happen. What are the probabilities for it? What are the chances? How will it happen or not? Will the certain thing occur or not? So whenever we are talking about chances of something to happen or not happen, that is what we mean by the word probability. In general, there are two types of probabilities. One is subjective probability and the other is objective probability. Subjective probability is something that comes with intuition, judgment, or an experience. For example, our parents, if someone is in a business sector, so if it's a small scale business, not in a complete industry setup, so if it's a small scale business, then while ordering stock or while ordering, seeing the inventory, how do you make a call about whether to bring a new product or not, whether how much to order a certain product in your area? So that only comes from intuition. They just judge the scenario, their market around them. They don't do any calculations. They don't have any formulas or any theories. They just go by their gut feeling, right? And they say that I know that this product is more likely that will uh, sell out, and this product is not that likely. So let's order a little less of this product and more of this product. So this likelihood solely comes from their gut feeling, their intuition, their experience from being in the market. So such kind of a probability is known as subjective probability. So that's not on our scope of study. What we will study is objective probability. Objective probabilities which comes from theories, which are obtained from formulas, from concepts. So such kind of a probability is what we are looking for. So in general, probability is of two types. And initially, probability was a part of mathematics. Later on, it became a part of statistics. Okay. You'll realize also when we do this, it's because it's a part of maths. Whoever had maths in 11th and 12th, you have studied probability. Right. So it was initially a part of mathematics. Later on, it got converted to statistics portion. In probability, there are two broad divisions, subjective and objective. Subjective is something that is completely based on personal judgment and experience and intuition. And when something is based on formulas and concepts and techniques, that is known as objective probability, which is in our study. Now, um, if I ask you, can we find probability in every scenario? Is it possible to do so? No. For example, suppose you are attending the class. So, what are the chances that I'm going to be in a good mood, in a jolly mood, in not in a stern mood, or whether I'm going to be very angry or I'm going to be very strict or whatever. So, it's online, it doesn't matter much. But suppose it would have been offline and you're talking about mood of the teacher. So, can you have a probability for that? No. You may wish, you may hope. But there is nothing that can determine the probability of me being in a good mood. And now, how do you determine a good mood? Right? So, what are the parameters? What do you say to be a good mood? If I'm smiling, if I'm very happy, or I'm given up your test or something, what do you determine as a good mood? Right? In such a scenario, the word probability doesn't exist. Right? So, it's not that we can obtain probability for every scenario. We can only do it in certain cases. For example, coins, whether if you toss a coin, you know that either head will appear or tail will appear. So we do find the probability of that. What is the probability of getting a head? What is the probability of getting a tail? You are throwing a dice. You get either 1, 2, 3, 4, 5, 6. Only these six possibilities are there. So you may ask probability of any one of them. You're picking up a card. You know there are only two colors of cards. They're red and black. So you may get any one of them. So you find a probability in some scenarios. In scenarios where you know what your total possibilities are. The only thing that you're uncertain is which one will come up in this particular case. So in maths, in general, any work is determined as an experiment. Experiment is another word that we use for work. And when we actually perform that experiment, we say it to be a trial. So tossing a coin is an experiment. And if I have tossed it twice, that means there are two trials of that experiment. Right? Throwing a dice is an experiment. I have thrown one dice three times. So I have three trials basically, right? So experiment is basically work, and when you actually, the number of times you perform that work is known as a trial. So we study probability only in certain experiments which are termed as random experiments. Random experiments are those scenarios in which all possible results, all possible outcomes are known to us. The only thing that is unknown is which one will turn up in one particular trial. Random experiment is an experiment in which all possible outcomes are known, but which one will turn up in a particular trial is uncertain. Only in those cases we find exapta probability. Now, the collection of all those outcomes, as I said, so if I toss a coin, what are the possibilities that I have? Either I'll get a head or I'll get a tail. So collection of these two outcomes is known as sample space. If I throw a dice, I know that I'll get 1, 2, 3, 4, 5, 6. So collection of these 6 outcomes is known as the sample space. If I throw a suppose card, it's either red card or a black card. So collection of all those cards is my sample space. So sample space is the collection of all these possible results, all these possible outcomes. Now, when we find probability for a part of this sample space. Part in math, we call it a subset. So event is what we call it. Event are subsets of sample space. So if I'm talking about coin, head and tail is my sample space. So I want to find probability of event of getting head. So getting head is a part of that sample space for which I want to find the probability. Getting tail is an event. It is a part of the sample space. It is a subset of the sample space for which I'm finding out the probability. Throwing a dice. So 1, 2, 3, 4, 5, 6 is my sample space. Getting an even number. So 2, 4, 6 is my event. Right? So event is a subset of the sample space for which we find the probability. Now that event can be divided into different categories. The first category, depending upon how many people are there in that event, is simple or elementary, composite or compound. So if I say event of getting head in a coin, there is only one favorable case. There is only one answer for that. That is X. So this is a simple or elementary event because I cannot break it down further. But if I say dice, getting an even number. So getting an even number is what? 2, 4 and 6. But this can be divided into getting 2, getting only 4, getting only 6. So this event is known as a composite or a compound event because I can divide them further. So any event which cannot be further divided is a simple or elementary event. An event which can be further subdivided is known as composite or compound event. Clear? Any doubt?
No, ma'am.
No,
Okay.
ma'am.
So initially probability was a part of
Max.
maths. How many divisions of probability are there?
2, ma'am.
2, subjective and objective. Which one is based on judgment?
Subjective.
Subjective.
Objective is the formula one. For what type of an experiment do we find probability? Do we talk about probability? A random experiment. What is a random experiment? In which all possible outcomes are known, but which one will turn up in a particular case is unknown. Now, so what is collection of all these possible outcomes? That is sample space. What is subset of sample space known as? Subset of sample space is known as event. Okay, for which we find the probability. Okay, now events can be simple or elementary if it cannot be broken down, and it can be composite or compound if it is allowed to be broken. Any doubts still here?
No, ma'am. No, ma'am.
Now, further, we can also divide event into a couple of more cases. First, understand. Now, this we will use in sums. Okay. First, are mutually exclusive event or incompatible event. mutually exclusive events or incompatible events. Those events that cannot stand each other. See, there are two friends in your group that doesn't talk to each other, or they cannot tolerate each other, right? So they'll tend to fight. So they will never go to a party together. So if A is attending that party, B says that I won't go to that party because A is already going. So such people are known as mutually exclusive. If one has appeared, then the other won't. So any two event which can never occur simultaneously is known as mutually exclusive event. Say, remember, as I said, you need combination. You also need set theory knowledge. I hope your union, intersection, all those parts are clear because we will use drastically here. All the formulas that existed for set theory are still true for probability. All of them, same to same. So mutually exclusive is if A appears, B won't appear. If B appears, A won't appear. There will be not a single case where A and B occurs together. For example, A is the event of getting a head, B is the event of getting a tail. So can it ever happen that head and tail occur together in a coin?
No, ma'am.
No. In
No,
one
ma'am.
particular throw, it can't happen. So head and tail are mutually exclusive. Odd and even. Then is there a number that is both odd as well as even?
No, ma'am.
No. So again, they are mutually exclusive. In a dice, multiple of 2 and multiple of 3, are they mutually exclusive? Can they occur together?
No, ma'am.
Yes.
Yes.
6.
6, ma'am.
6, no? It's a multiple of 2 as well as 3. So if 6 appears, both cases will be satisfied. So yes, they can occur together. If 6 appears, then 2 event will also occur. The event of getting a multiple of 3 will also occur. So yes, they can coexist. Yes, they can occur simultaneously. So no, they are not mutually exclusive. Mutually exclusive means not being together. Nothing common. So in odd and even 2, 4, 6, 1, 3, 5, there's nothing common. So yes, they are mutually exclusive. Multiple of 2 and multiple of 5. Okay, fine. 2, 4, 6, and 5. Nothing is common. They are mutually exclusive. So if there are no common element, then it is said to be mutually exclusive. Understood?
Yes, ma'am.
Yes, ma'am. Yes, ma'am.
Second is exhaustive. Exhaustive. The word itself gives away. Exhaustive. I'm exhausted. What do we mean by that word? That as much energy that I could have put I've already done that. I have no shred of energy left with me, no willpower left with me that I can work longer, that I can work even a bit more. That is being exhausted means, right? That is what here happens. If if I have two or more than two events, when will I say that that is exhausted? If those event, two, three, how many? Those event have completely squeezed out the entire sample space. They haven't left a single element with the sample space that they haven't used. For example, dice. Dice is what? 1, 2, 3, 4, 5, 6. So one case is set of even numbers. So what will A take? A is set of even numbers. So what are the elements that will go to A?
2, 4, 6.
2, 4, 6. Okay. But then B says that I am the set of all order numbers. So B will take
1, 3, 5.
1, 3, 5. So between A and B, they have squeezed out all the elements of the sample space. Yes or no? Sample space had how many elements to offer? 1, 2, 3, 4, 5, 6. Those 6 elements. Now A and B, did they leave out any of the element or they took all of them?
All of them.
Took
All
all
of
of
them.
them.
So this is what exhausted means. They have exhausted the sample space. They haven't left a single element in the sample space unused. If I say multiple of 3 and multiple of 4, multiple of 3 will be
3 and 6.
3 and 6. Multiple of 4 will be
4, ma'am.
4. Are they mutually exclusive?
Yes, ma'am.
Okay. Are they exhaustive?
No, ma'am.
No. They are left out 1, they are left out 5. There are so many elements they have left out, right? So they are not mutually exclusive. Am I clear? Exhaustive
Yes, ma'am.
and mutually exclusive. Mutually exclusive means they cannot occur together, they cannot coexist, they have nothing in common. Exhaustive means that if I combine them, I have got the entire sample space. If I combine them, I have got the entire sample space. If I combine set A and set B, they give me the entire sample space. Clear?
Yes, ma'am.
Yes, ma'am.
Third is equally likely or mutually symmetric or equiprobable. Equally likely, mutually symmetric or equiprobable. That means chances of something to occur are same. For example, head and tail, 50-50% chance, right? There were two events, one is head, one is tail, so equal. Even and odd, three favorable cases out of six. They are they're equally likely. Multiple of 4, multiple of 5. Multiple of 4, only one element, 4 itself. Multiple of 5, only one element, 5 itself. So again, they're equally likely. Yes or no? Understood? Equally likely. Equally likely means favorable cases. The quantity is same, their probabilities are same. Probability of A will be same as probability of B. Understood?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am. Yes,
Yes,
ma'am.
ma'am.
Can you give me an example which is mutually exclusive as well as equally likely? Which is mutually exclusive as well as equally likely.
Hidden tail.
Yes, head and tail. They're equal, one favorable to both of them, and they're mutually exclusive. They're even exhaustive if I'm not.
Yes, ma'am.
Yes,
So
ma'am.
they're all the
Exhausted.
three. Can you give me an example which is equally likely but not mutually exclusive? They are equally likely but not mutually exclusive. They are
Even
equally
in
likely.
odd numbers of dice.
Sorry?
Even in odd numbers of dice.
No. How are they not mutually exclusive? They are mutually exclusive. One has 2, 4, 6, one has 1, 3, 5. They are mutually exclusive. I don't want mutually exclusive. Normally, you can say set A 2, 4, set B 4, 5. So both of them have 2, 2 elements. So they are equally likely. Yes, no. But are they
Yes, ma'am.
Yes,
mutually
ma'am.
exclusive?
No, ma'am.
Why?
No, ma'am.
4 is
4 is
4
common.
is common. Clear?
Yes, ma'am.
Yes, ma'am.
They are equally likely but not exhaustive. Equally likely but not exhaustive. What happened? Equally likely but not exhaustive. Very easy. 4, 5 in dice. A is set of getting a multiple of 4, it's 4. B is set of getting a multiple of 5, that's only 5. So both of them has only one element. So are they equally likely?
yes, ma'am.
Yes. Are they exhaustive?
No.
No, no.
Why?
The other digits are like 1, 2, 3.
2, 3, so many are left. Clear, everybody? Equally are mutually exclusive but not exhaustive. Mutually exclusive but not exhaustive. Mutually exclusive but not exhaustive.
4 and 5 are yes.
Yeah, fine, perfect. Everybody clear?
Yes, ma'am.
Yes, ma'am.
So anything is allowed. They can be all the three, they can be one, but may not be the other. Everything is possible. Yeah. Now, the fourth type is independent events. Independent event means the word itself gives away independent. Two events are said to be independent if the occurrence or non-occurrence of an event does not affect the occurrence of another. For example, if I toss a coin, I got a head. I toss it again. Will it matter that previously I have got head?
No, ma'am.
No, ma'am.
When I toss a
No,
coin
ma'am.
for the second time, in that, while getting head and tail, does the probability vary if you know that previously you have got a head or previously you have got a tail? Does the probability vary?
No, ma'am.
No. This is being independent. Suppose from a deck of cards, I pick up a card that is red colored. I keep it with me. From the remaining, I pick up another card. Again, I pick up a card. Now I haven't told you which one is this. Okay? It may be a red card, it may be a black card. I keep it with me. I pick up another card. Can you tell me what is the probability of my second card to be red? What is the probability that the second card is a red color?
50-50.
No. You need to
1 by
know what I picked out first. If I have picked
25
up
by
red,
26.
how do you know that? I did not tell you which one is the first card. If I have picked out the first card red, then yes, 25 by 50 to 1. But if I picked out a black card, then automatically the quantity of red card is more. So red card will have more probability. So in this case, do you not want to know which one is my first card?
Yes, ma'am.
So this is not independent because it matters that another event has occurred or not and what has happened. So when it matters to you, then it will not be independent. When it doesn't matter, all the coin cases are independent. All the dice cases are independent. So in those cases, it doesn't matter what you got earlier. Is it understood?
Yes, ma'am.
Can mutually exclusive and independent occur at the same time? If yes, why and when? If no, why? Can be two events be mutually exclusive as well as independent at the same time? Think and tell. Waiting for your answer. You don't have an answer? What is mutually exclusive? Definition.
Cannot occur at same time.
Okay. So that means if A has come, then B will.
Not come.
Not come.
So is it affected by B? A?
No.
It is effective.
It is.
Effective. It's not something.
A lot affected, na? That if A has come up, then B said that I won't even go. Affected to that extent. Understood? And what does independent want? That whether A exists or not, B should not even be aware of. So is that the case? In mutually exclusive, we say that B is so much affected by A that if A is coming, then B will not even show up. And in independent, we say whether B shows up or doesn't show up, it should not affect B. Right? So can these the two definitions itself are self-contradictory, right? So two events can never be mutually exclusive and independent at the same time. Rest everything else can happen, but mutually exclusive and independent together cannot happen. Understood?
Yes, ma'am.
All of you understood till here?
Yes, ma'am.
Okay, let's
Yes,
write down
ma'am.
till here. Let's note down till here, then we'll move forward. Probability. Initially, probability was a part of mathematics. Two divisions of probability. Subjective. Based on experience and judgment. Objective. Based on formulas and techniques. Then we talked about random experiment. An experiment in which all possible outcomes are known, but which one will turn up in a particular trial is uncertain. Then comes sample space, denoted by capital S. It is the collection of all possible outcomes. Let us for some instances write sample space. If it is coin, the formula is 2 to the power n. N is the number of coins or number of times you're tossing the coin. So if I have only one coin, then 2 power 1, 2 outcome. If I have 2 coin or I am tossing 1 coin twice, then 2 to the power 2, 4 outcomes. If I'm tossing a coin 3 times or I'm tossing 3 coins together, I'll get 2 to the power 3, 8 outcomes. So 10 coins will give me
2 to the power 10.
Power 10.
2 power 10. So 1 coin. Sample space will be h comma t. It is written as a set. 2 coins. So head, tail, head, tail. Both the possible h, 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 t, t, h, t, t. Three coins. So for 2 coins first, third coin, So this will pair up with both H, 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 T. This will pair up with both H, T, H, H, T, T. This one will pair up with both T, H, H, T, H, T. This one will pair up with both T, T, H, T, T, T. Same way, dice. Formula is 6 power n. 1 dice, 6 outcome, 2 dice, 6 square, 36 outcomes. So, 1 dice. 1, 2, 3, 4, 5, 6. 2 dice. If first one has got 1, the second one can get anyone from 1 to 6. So, 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6. Then comes 2's turn. 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6. From this, you tell me how many times 2 appears? Once. Only once. Once means exactly once. In how many element 2 appears exactly once? Count. 2 appears once.
11 times.
10.
10, ma'am.
Yes. 1, 6, 7, 8, 9, 10. 10 times. If I would have said at least once, that means this one would have been also allowed. Then we would have said 11 times. Yes?
Yes, ma'am.
Doublet. Doublet means both the numbers are same. These. 1, 1, 1, 2, 1, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. These are doublets. So there are 6 doublets. Yes?
Yes,
Yes,
ma'am.
Now
ma'am.
sum of the numbers. Total of the. So if you add 1 plus 1, 2. These two when added, 1 plus 2, 2 plus 1 will give you 3. These when added, 1, 3, 2, 2, 3, 1 will give you 4. These 4 when added, 1, 4, 2, 3, 3, 2, 4, 1 will give you 5. When we add them, these 5 numbers will give you a total of 6. These 6 numbers will give you a total of 7. Total 8. Total 9. Total 10. Total 11. Total 12. Only one people give you. Understood?
Yes, ma'am.
Then comes event. Events are subsets of sample space. Subsets of sample space. So first, simple or elementary cannot be broken further. Example, single edge, single one. Composite or compound. Can be broken down, can be decomposed into further events. Example, HTTH. I can break it down. Again, types of events. First, mutually exclusive or incompatible events. What were these?
Can't occur at the same time.
Cannot occur simultaneously. No common element. In set theory, which operation gave us common?
Intersection.
Very good. A intersection B should be nothing. Nothing is null set. So automatically, probability that A and B will occur together will be 0. Second, exhaustive. So when combined, it should give you.
Sample space.
So A union B should be S. A union B should give you sample space. That means probability A union B should be 1. Third, equally likely or mutually symmetric or equiprobable. When their probabilities are same. Fourth, independent event. Occurrence or non-occurrence of A does not affect the occurrence of B. That means if you want A and B together, it is simply basically they occur individually. There has nothing to do together. I want 2 in dice and I want head in coin. So find 2 in the dice probability separately. Find head in the coin probability separately. Since you want both, multiply them. So independent means instead of every intersection, we will be able to write multiplication. Independent means instead of intersection, we can write multiplication. Clear?
Yes, ma'am.
Written till here.
Yes, ma'am.
Yes, ma'am.
Yes,
Yes,
ma'am.
ma'am.
Now, there are 3 different definitions of probability. We will use only one. But for theory purpose, we have 3 definitions of probability. The first one which we will use also, classical definition or a priori definition. Probability of A will be number of cases favorable to A by total number of cases. The limitations of this definition is number of events have to be finite. You're tossing a coin once, twice, thrice, you have to know. Events has to be mutually or equally likely. Like head and tail, 1, 2, 3, 4, 5, 6. They're all equally likely. Now, to remove this definition came another definition that is relative. We will use only in sums this definition. The rest is only theory. Just remember bits and parts. Don't even need to remember the entire one. Second definition is relative frequency definition. Relative frequency definition. This says probability of A limit n tends to infinity favorable event by total event, provided the limit exists and tends to a finite value. Just remember the limit definition is the relative frequency. That's it. Tends to a finite value. The third definition, axiomatic or modern definition. Just remember one line. Probability is a real valued function. Just remember this line. In exam, you only need this much. Rest you can take. Such that I'm writing certain condition. As you do the sums, you'll realize probability can never be negative, so greater than equal to 0. Total probability has to be 1. And third, for any sequence of mutually exclusive events, A1, A2, A3, and so on, probability of their union. Instead of union, you will be able to write addition. Just add them individually. Just add them individually. Just remember the limit definition is relative frequency definition, provided the limit exists and tends to a finite value. And in axiomatic and modern definition, we treat probability as a real valued function. Any doubts? Everybody clear?
Yes, ma'am.
Yes, ma'am.
This was the theory portion of probability. In our next session, okay, we'll be starting only the sums. So I'll really advise you all, go through the set theory, union, intersection. I'll need all the formulas and also go through the combination. Combination, I only need the formulas, the tricks. That's it. Only the combination part. I don't want permutation. Only the combination part. Revise these two. Otherwise, you won't understand probability sums. Thank you.